Force, work, and energy review 11. Based on the figure, determine all of these things. How long does it take to reach point 1 here? Let's look at our launch velocity. I'm seeing 50 meters per second launch speed at a 53-degree angle. That tells me that this is a 3, 4, 5 right triangle. So that means that Vx is 30 meters per second and Vy initial is 40 meters per second. Just based on that being a 3, 4, 5 right triangle, which means the vertical speed we're assuming we're on Earth is going to change by 10 meters per second each second. So I think it'll take 4 seconds to reach the top of its path. What will its velocity be at the top? At the top, it will only have its x component of velocity at that instant, which is constant for the whole time this thing is in the air. So that'll be 30 meters per second. What's the height above the launch point? All right, let's see. Let's take our vertical velocity to start with, which is 40. The vertical velocity at the top is 0. The average is 20. It averages 20 meters upward every second for 4 seconds. How about it's 80 meters above the launch point at point 1? How long does it take to reach point number 2? Took 4 seconds to go up that high. It takes 4 seconds to come down that high. So a total of 8 seconds. What's its velocity at point 2? It's going to be, assuming there's no air resistance, it's going to be 50 meters per second, but now it's going to be 53 degrees below horizontal, not above horizontal. Time to reach point 3. All right, so how are we going to figure that out? Time to reach point 3. At point 2, we know that it's moving downward at 40 meters per second, and it's moving over at 30 meters per second. And we're told that it falls 45 meters from here to here. So 1 second after this, it's going to be going 50 meters per second downward. And if we kind of guess and check here, the average between 40 and 50 is 45 for 1 second, and that would be our 45 meters downward. So in other words, it takes 1 second to get from 2 to 3. So the time to reach 3 would be 1 second more than it took to reach 2. So I'm thinking 9 seconds. The range then from launch to point 3, it's in the air for 9 seconds. It moves horizontally 30 meters each second. So how about 270 meters? That's the range. All right, what's the work done by gravity between launch and point 3? So if we look at our picture here, the work done by gravity is just going to be m times g times the change in h. So let me start writing that down here at the bottom. The work done by gravity is equal to m times g times the change in h. M is given in the diagram. You can't see it now, but it's in there as 2 kilograms. G we're going to take to be 10. And what's delta H? Delta H, we're looking at the diagram now, between launch and 3, the fact that it goes up and comes back down doesn't make any difference. It's dropped 45 meters. So the delta H is 45 meters. And we do that in our head, 450 times 2, 900. 900 joules. Now, does gravity do positive or negative work in that path? Well, we end up lower down. So gravity does positive work. So I'm getting positive 900 joules for that one. Determine the mass's kinetic energy at launch and also at point 3. So let's try that. Kinetic energy at launch is going to be 1/2. The mass is 2. And then the speed is 50 squared. 1/2 mv squared. This is at launch. That's going to come out to be 2,500 joules. What about at point 3? Well, let's find the velocity at point 3. The velocity at point 3 equals what? it's going 30 meters per second horizontally. And then we decided, rewind the video if you need to, we decided that it was going downward at 50. So that means that the total speed, you could figure it out, use the Pythagorean theorem. I got to be 58.3 meters per second. So what's the kinetic energy here at 0.3? It's going to be 1/2 times m times v squared. And when you crunch that out, you end up getting 3,400 joules. And finally, show that the answers to our earlier parts conform to the work energy theorem. We'll check it out. The work done, we said, was 900 joules. Let me put that up here one more time. The work done by gravity was 900 joules. And look what we just discovered. The change in kinetic energy, 900 joules. And remember that the net work done should equal the change in kinetic energy, and it does.